If you study physics any length of time, you've probably heard of the concept of length contraction. And that's related generally to relativity theory, special relativity, the Michelson-Morley experiment. And it came about originally when Fitzgerald and Lorentz tried to solve the problem with the Michelson-Morley experiment by considering that perhaps the lengths are contracted in space, which allows photons to travel different distances that they would normally. As I discussed in a previous video, the permittivity and permeability of space are the same in both directions, all directions. And so the speed of light is the same in all directions. And there's no directional dependence as they imagine. So there never was an ether drag effect that could have been measured by the Michelson-Morley experiment. But to go into a little more detail about why there can't be length interaction and why it's one of the greatest lies in physics, we have to start with the existence of the quantum field theory, and the quantum field in particular. We know the quantum field exists, and I've been through evidence in previous videos. If you can see, there is no ether. I discuss 15 different evidence-based proof for the existence of quantum field. And so it exists, it's real, we have to deal with it in any theory that we're discussing. And one of the real keys we find is that the wavelengths of the quantum field are what determine the dimensions of space. And the frequencies of the quantum field determine the clock rates. Because frequency is in cycles per second, you have to have clocks before you can have frequency. And so that's where the clock rates and frequencies come from. And because the quantum field is made of dipoles, it has what's called van der Waals forces, where the dipoles oscillate a little bit. Well, they also have torque, where if a dipole's rotating, there's torque from all the other dipoles around that are trying to prevent it from rotating. And because of that torque, the quantum field is self-regulating. And it even regulates its own wavelengths and frequencies. So the dimensions and time of space emerge from the quantum field without having any sort of outside source of interaction or any outside source of anything else. Now we can compare that to the Fitzgerald-Lorentz type relativity or Einstein's relativity, where they just imagined that space could change its dimension. They didn't have any physical mechanism for how this could happen, or any physical description. And if you consider the basic definition of space, it's more of an abstract concept of a container that contains all matter. And then the matter gives it properties. So if there could be space without a quantum field, it would have no physical matter, it would have no physical properties, it would be dimensionless and clockless. Excuse me. So, under Einstein's view of special relativity, we have these imaginary, non-physical, fictitious dimensions and clocks. And then he builds his theory of relativity and general relativity, which are based on dimensions and clocks, from this imaginary beginning into an imaginary theory. And so if we want to develop a real theory, we have to start with real dimensions and real clocks, and those come from quantum field theory. And so the next important thing to recognize about quantum field is it has its rest frame. It has one frame of reference where it appears to be at rest and not moving. And we can define that as its lowest energy state, the state where the rotation appears to be on average, because if an observer was moving relative to it, it would make the dipoles appear to be rotating preferentially in one direction versus the other direction. And so there's one frame of reference always, and there must be, so that you have this basic rest frame. And that's where the permittivity and permeability are the lowest and the speed of light is the highest, which is something that Maxwell recognized back in the 1860s. And if you tried to imagine a space where you could infinitely vary the rotation and motion of the quantum fluctuations so that they always appeared to be in a rest frame, even when an observer is moving the speed of light in a million different directions simultaneously, it just makes no sense. I mean, there's no sense that you can have a million or a billion multivariable rest frame, reference frame that always looks like it's a rest frame. It's total nonsense. So there has to be a rest frame. And what's key there is that the rest frame is where the dimensions and clock rates of space are determined. And so that's where the lengths of space are determined. Space by itself doesn't have lengths because it doesn't have any dimensions to begin with. And so space's lengths are determined by the quantum field in the quantum field rest frame. Then, if you have an observer that's moving and you want to see what the observer sees, the first important thing to note is the observer does not change the dimensions in the quantum field rest frame due to their motion alone. There is, of course, general relativistic effects, and that's because the observer has mass. The mass changes the quantum van der Waals torque, and the change in quantum van der Waals torque changes permittivity, permeability, wavelengths, frequencies, clock rates, everything we expect from general relativity. But in terms of basic relativity, not general relativity, we have no effect like that. So a moving observer does not change the dimensions, unlike in special relativity where it's assumed that observer moves and all of a sudden dimensions are length contracted. So space doesn't have any dimensions to begin with. Space certainly can't have dimensions that are length contracted. It's just not physically possible because it's not physically real. You're dealing with imaginary dimensions and imaginary length contraction, which doesn't actually really happen. What you do have when you have a moving body is when a body moves, it can cause torque in the quantum field. And that additional torque in the quantum field has energy back on the object, which is where inertia comes from. And so you do have this inertial energy and inertial mass that becomes relative to a moving object, and that can be relativistic energy or mass if something's moving at velocities close to the speed of light. But that doesn't cause length contraction. Neither one of those does. It's just a quantum field interaction between the moving body and the quantum field, and the energy state the moving body has to be in order to first obtain that velocity, and then it will sustain that velocity naturally through space. And another important thing to recognize about photons is the whole Michelson-Morley experiment was based on relativistic effects on photons, or at least so they thought. But photons travel in the quantum field rest frame. They're producing electric and magnetic fields, which causes the quantum field dipoles to be polarized and magnetized. So if the photon were sentient, it would just see that it's causing this rotation in the quantum field rest frame. It wouldn't be able to tell what its initial velocity was unless it somehow knew what its initial frequency was from its source versus its frequency and wavelength in the quantum field rest frame. So what happens is, as soon as, if you have a moving source that emits a photon, as soon as that photon leaves the source, it's in the quantum field rest frame, and it doesn't even have any memory of what its source was doing. We can only back that in because we can make assumptions as to what the original wavelength of the photon was based on similar wavelengths on Earth. So there really isn't a relativistic effect. And as far as the light goes, there's no length contraction of light or wavelength contraction of light while it's traveling. You only see the wavelength contraction when something gets absorbed or detected at a detector, and then we can measure the wavelength at the detector. And those things can be described through basic Doppler effects, the standard Doppler shift for light and also the relativistic Doppler shift for light. That will tell us what the wavelength shift is going to be. It's not an issue with wavelengths being changed during transmission. Now that said, there are still general relativistic effects where the wavelengths of light, the speed of light, and the clock rates of light change for, say, a beam of light passing the sun, which causes the Shapiro delay, for example, also causes the bending of light, causes clocks to slow at different altitudes above the Earth because of the increase in van der Waals torque near a large body of matter. But those are general relativistic effects that are separate from the effects on light due to just standard relativity. So we really there's no link contraction, and there's no space contraction. There's no link contraction of a photon. There's no space contraction. So it's a lie. And so anytime you hear that, you can tell people that space doesn't have dimensions, so space doesn't have links that can contract. So space link contraction is a lie and shouldn't be part of the theory, that people should be using quantum field theory and using the dimensions and clock rates from the quantum field, wavelengths, and frequencies, and using that to determine relativistic effects. But if you use quantum fluctuations and quantum field theory to explain relativity, then that makes relativity and general relativity electromagnetic effects that are part of quantum field theory. And there's a lot of resistance to that in the physics community. They don't want to unify general relativity and relativity with quantum field theory. They want to maintain them separate because it means that some of their baseline assumptions are wrong, including that all along that they believed in these imaginary distances and clocks in space that don't really exist. Well, I hope you enjoyed this video, and if you do, please share, like, subscribe, and look for my future videos. And if you want to learn more about quantum field theory, I have some books. And my latest book, Goodbye Quarks, the Onium Theory, is about a new theory I developed where I can describe all particles as pairs of particles that are relativistically orbiting each other. And so that I'll do more videos on that so I can describe that to you. So I hope you enjoyed the video. Thanks a lot.